Suppose you got A star B is equal to some C, then C should belongs to the given set. Thus, binary operation is a function from the Cartesian set A cross A to A, such that star A comma B is defined in the form of A star B. Commutative law says A plus B is equal to B plus A, AB is equal to BA. So this is how we can define a binary operation on addition and multiplication. 0 is not identity in n because 0 does not belongs to natural numbers. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. We are in the chapter Relations and Function, and in today's session we'll be studying the concept on binary operation. So what do you mean by this binary operation? So for that, let's study a simple definition. Consider a non-empty set A and star B an operation on the set A. Then star is said to be binary operation when if for all A comma B belongs to A, that should implies A star B is equal to C belongs to A. I'll take an example. Suppose if n is the set of natural number and let me take plus as the binary operation. When we say that it's a binary operation on that set, that is on the set of natural number. Suppose I take any two elements in A. Let me take two elements from the set N. Let me take 2 and 3. We know that 2 and 3 belongs to N. Let's take the binary operation 2 plus 3. What is 2 plus 3? 5. Does 5 belongs to N? Yes, 5 also belongs to N. Then inly we say plus is binary operation on N. So this is how we define a binary operation. So whenever you have any set A and star is any operation on the elements of the set A. Suppose you got A star B is equal to some C, then C should belongs to the given set. Then only we say that it is a binary operation. Let me check a binary operation minus on the set of natural numbers only. Let me take the same two numbers. We know that 2, 3 belongs to N. What is 2 minus 3? 2 minus 3 is minus 1, but minus 1 does not belongs to the set N. So therefore, what we can say, minus is not binary operation on N. So this is how we define a binary operation. Similarly, we can say product or multiplication is binary operation on N. Whatever the elements you take from the natural number, you multiply it, you will get back the natural number. But division is not binary operation. 2 by 3, suppose you take 2 by 3 is not a natural number. So therefore, division is not binary operation on N. Similarly, suppose you take the set of integer, plus is a binary operation on integer, minus is a binary operation on integer because 2 minus 3 is minus 1 which belongs to the set of integer. Product is also binary operation on the set of integer, but division is not binary operation on the set of integer because a fraction is not contained in the set of integer. So based on the given domain set, we have to verify the binary operation to say whether it is a binary operation or not. So this is the definition. So here we consider the binary operation as a function itself. So therefore, let A comma B belongs to A. A is a set and star is said to be binary operation on A. Then star is a function. It's a function from A cross A to A. So it's a Cartesian product A cross A to A given by star A comma B is equal to A star B. So this is the standard definition of the binary operation. Thus binary operation is a function from the Cartesian set A cross A to A such that star A comma B is defined in the form of A star B. Now check whether the operation star defined below is a binary operation or not. On Z plus define star by A star B is equal to A minus B. Z plus is nothing but positive integers. So then what are the elements we have here? 1, 2, 3, etc. until infinity. So these are the elements. Now take any two elements from this set. Let me take 1 and 2. So 1 star 2, if I take, it should be written in the nothing but 1 minus 2, which is equal to minus 1. But minus 1 does not belongs to z plus. Minus 1 belongs to z but not belongs to z plus. So therefore what we can say, star is not a binary operation on z plus. So based on the domain and the operation given, we have to verify whether it is a binary operation or not. Next one, on z plus, define star by a star b is equal to ab. Obviously I said positive integers 1 to infinity. Take any two from this set. Let me take 2 comma 3 belongs to z plus. So take 2 star 3. It should be defined in the form of 2 into 3. What is 2 into 3? 6. And 6 belongs to z plus. So therefore, star is binary operation on z plus. So these are all very simple. They may ask you for 1 mark question. Next one, on z plus, define star by a star b is equal to mod a minus b. Again the same set of positive integer. Take any two elements, 3 and 5. 3, 5 belongs to z plus. So 3 star 5 is nothing but 3 minus 5, which is nothing but modulus of minus 2, which is 2. So whatever you get inside, you get a negative number, it becomes positive since you have a modulus function. So positive means it belongs to the set of positive integer. So therefore here, star is a binary operation on z plus. So the same problem when you have taken in the form of a minus b, it was not a binary operation because you are getting a negative value which is not in the set of positive integers. But here it is in the set of positive integer. Next one, on Q, define star by a star b is equal to ab by 3. You can take any rational number. Let me take 1 by 2 and 3 belongs to Q. So then 1 by 2 star 3 can be written as 1 by 2 into 3 divided by 3. 3, 3 which is half again, which belongs to set of Q. So therefore I can say here star is binary operation on Q. So based on the binary operation defined and the given set, we can say whether star is binary operation or not. So since binary operation is a function, we have certain laws whether it satisfies or not. So let's see the first law, a commutative law. What does the commutative law says? So the commutative law says a plus b is equal to b plus a, ab is equal to ba. So this is how we can define a binary operation on addition and multiplication. Similarly, for any binary operation, we say it is commutative. That is, binary operation is commutative if a star b is equal to b star a for all a comma b belongs to a. For any operation, however the function is defined, if it satisfies a star b is equal to b star a, we say it is a commutative. So let me define a function star from r cross r to r defined by a star b is equal to a plus 2b. So now here you can clearly say a star b is equal to a plus 2b. What is b star a? B star a is nothing but b plus 2a. So clearly see they are not equal. So here a star b is not equal to b star a. So therefore this is not commutative. We can say it is not commutative. Now let me take one more function from the same set of real numbers to real numbers in the form of a star b is equal to ab. So a star b is equal to ab means, see, take any two example, b star a is nothing but ba, which is same as ab only. So this is commutative. So whenever you have a star b is equal to b star a, then we say it is commutative. So this function is commutative here. So we can also take a counter example by verifying with numerical values also to show that whether it is commutative or not. Next one, we have associative law. You are already familiar with what is associative law. So binary operation star and the set A is associative if A star B star C is equal to A star B star C for all A comma B comma C belongs to A. So let me take an example. Let star is a binary operation defined on the set of real numbers, two real numbers defined by A star B is equal to A to the power B. So I have taken in the form of A to the power B. So let me take A star B star C here. So A star, how is B star C? It is written in the form of B to the power C. Now we have A star B to the power C. How this is written? A to the power B to the power C. Now let me take one more example. A star B star C. So how is A star B is written? A star B is written A to the power B star C. Now how this is written? Again this is A to the power B to C. Here it is A to the power B into C. A to the power B into C here. So here B has a power C, but here BC is multiplied. So they are not equal. So this is not an associative. Now let's take one more example. So let me take A star B is equal to AB by 2. So let's verify A star B star C. So what is A star B star C means it is BC by 2. Again A star BC by 2 means it is A into BC by 2 whole divided by 2, which is equal to ABC by 4. Now let's check it for A star B star C. A star B means AB by 2 star C. Here it is again AB by 2 C divided by 2, which is ABC divided by 4. So clearly from these two, we got A star B star C is equal to A star B star C. So therefore, we can say star is associative. So this is how we prove whether the star is an associative or not. Next one, an identity element. So what is an identity element? So an element E belongs to A is said to be an identity element for the binary operation star if A star E is equal to E star A is equal to A for all A belongs to A. So under any binary operation, if you are taking with respect to the identity element with another element A, then the result should get back to A only. So A star E, E star A is equal to A, then only we say E is the identity element in the set A. So I have taken an example here. 0 is the identity on Z under addition. Why? Because whatever you add to any number in Z with 0, you will get back the same result. For example, minus 2 plus 0 is also minus 2, 3 plus 0 is also 3, minus 3 plus 0 is also minus 3. However you add with respect to 0, you will get back the same element. Hence we say 0 is the identity on Z. But remember, 0 is not identity in N because 0 does not belongs to natural numbers. So therefore, there does not have any identity element in the set of natural number. We do not have any identity element in the set of natural number. So therefore, all the sets do not have an identity element which satisfy this condition. So only when A star E is equal to E star A is equal to A is possible, then only we say certain element is an identity element in the given set. Next, one is the identity on N. So under multiplication. So when you multiply any number with respect to 1, you will get back the same number. So therefore we call 1 is the identity element in N under the binary operation multiplication. 0 is the identity on Z under the binary operation addition. Next one, let star is a binary operation with E belongs to A. An element A belongs to A is invertible if there exists A inverse A, such that when you take a binary operation with A and its inverse, then it should result in an identity element. Then we say that A inverse is the inverse of A. For example, under the set Z, under the binary operation addition. So if I take minus 3, then plus 3 is equal to 0. Since 0 is the identity element in Z, so for minus 3, plus 3 is the inverse. Similarly, for plus 3, minus 3 is the inverse. But what happens in the set of natural number under addition? Since natural numbers do not have any identity element, it does not have inverse element also. For example, for 3, there is no minus 3 because minus 3 does not contains in n. Since natural number do not have any identity element, obviously it does not have any inverse element. Now, under multiplication in the set of rational numbers Q. Suppose 3 is the element I have taken, then 1 by 3 is the inverse element because 1 is the identity element under Q for multiplication. So therefore, if A is the element you have in the set of rational number, then 1 by A is the element which is inverse in Q. But what happens under the set? If I write 3, what is the identity element of Z under multiplication? 1. But 1 by 3 does not belongs to Z. So therefore, there is no inverse element under multiplication on the set of integers. So therefore, for any property to be hold, the set under the binary operation matters. Let's move on to the questions now. For each operation star defined below, determine whether star is a binary, commutative or associative. First, we will verify whether it is binary, then we will verify whether it is commutative or associative. On Q, define A star B is equal to AB plus 1. Take any example. Let me take 1, 2 belongs to Q. Then what is 1 star 2? 1 star 2 is 1 into 2 plus 1, which is 2 plus 1, which is equal to 3, belongs to Q. So take any number in the set of rational number, you will get back the same result. You will get back the result which belongs to rational number only. So therefore, star is binary operation on Q. So this is the first one. Let me see whether it is a commutative or not. So here we have A star B is equal to AB plus 1. We know that A into B is same as B into 3 because 2 3s is 6, 3 2s is also 6. So A into B is nothing but B into A plus 1. AB plus 1 can be written as A star B. Then how A plus 1 can be written? It can be written as B star A. So we got A star B is equal to B star A. Therefore, star is commutative. Next, we will verify the associative property. We have A star, B star, C. So, A star, BC plus 1. Because B star C means BC plus 1. Now, A star BC plus 1 means we have A into BC plus 1 plus 1. That is equal to ABC plus A plus 1. Now, let's verify for A star B star C. So, here it is AB plus 1 star C, which can be written as AB plus 1 into C plus 1. Again, star C means AB plus 1 into C plus 1 we get. So, that is equal to ABC plus C plus 1. Clearly, you observe they are not equal. Since they are not equal, what I can conclude here? Star is not associative. So in general, we can take A, B, C to prove also, or you can take any numerical values to show that it is not associative. Next, on Q, define A star B is equal to AB by 2. I already told you AB by 2 is an associative. Let's verify whether it's a binary operation or not. Take any example, 1 by 2, 3. So, then belongs to Q. Then here, 1 by 2 star 3 is equal to 1 by 2 into 3 divided by 2, which is 3 by 4. This belongs to Q. So therefore, I can clearly say star is binary operation on Q. Next, second one, let's see whether it is a commutative or not. A star B can be written as AB by 2. AB can be written as BA by 2. BA by 2 can be written as B star A. So therefore, I can conclude star is commutative. Next, let's see whether it is associative or not. A star B star C means A star BC by 2, which can be written as ABC by 4. Next, here also A star B star C means AB by 2 star C. Again, it is AB by 2, C by 2, which becomes ABC by 4. So we are getting they are same. So that is star is associative. Thus, the given binary operation is both commutative and associative. Next one. On Z plus, define A star B is equal to A to the power P. So here on Z plus means it's a set of positive integers. That is, it is a set of natural number. Take any two example. 1 star 2, which is nothing but 1 square, which is again a integer, which belongs to Z plus. So therefore, star is binary operation. Now let's see whether it is a commutative or not. Take any two example. Let me take 2, 3 belongs to Z plus. What is 2 star 3? It is 2 cube, which is nothing but 8. What is 3 star 2? It is 3 square, which is nothing but 9. So clearly we have 2 star 3 is not equal to 3 star 2. That means A star B is not equal to B star A. So therefore we can conclude star is not commutative. So let me take a counter example by taking numerals. Let me verify 2 star 3 star 4, which is 2 star 3 to the power 4, which is equal to 2 star 81, which is 2 to the power 81. Similarly, let me check 2 star 3 star 4, which is 2 cube star 4, which is 8 star 4, which is 8 power 4. Obviously, they are not equal. So, therefore, A star B star C is not equal to A star B star C. So, therefore, star is not associative. So, thus, this is how we can prove whether star is binary operation, star is commutative, star is associative. Next question. On Q, star is defined by A star B is equal to AB by 4. Find the identity element, if any. If there exists any identity element, we have to find that identity element. What is the condition for identity element? A star E is equal to E star A is equal to A. So, let me check. Now, take this result. A star E is equal to A. So, if this is possible, then identity element exists. Now, how they have defined A star B? In the form of AB by 4. So, therefore, here A star E can be written as A E divided by 4 is equal to A get cancels. So, we are getting E is equal to 4. Thus, there exists an identity element which is equal to 4. So if you substitute here 4 in the place of B, we are getting the value as A itself. So therefore, E is the identity element that is equal to 4. Next one, let star be the binary operation on n given by A star B is equal to LCM of A comma B. Find 5 star 7. A star B is nothing but LCM of A and B. So 5 star 7 means LCM of 5 and 7. So this is equal to LCM of 5 and 7. So that is equal to 35. Next we have 20 star 16, which is nothing but LCM of 20 and 16, that is equal to 80. Note one more point here. When number of elements in the set A is very small, we can express the binary operation star through a table called operation table. Whenever you have very less number of elements, we can substitute those elements in the form of operation table, where we can verify whether the star is binary operation or commutative or associative, whatever the condition they will ask with the help of the operation table. Now let's verify few problems with the help of operation table. A star defined on the set 1, 2, 3, 4, 5 by A star B is equal to LCM of A and B is a binary operation. Justify your answer there. So here the set is given 1, 2, 3, 4, 5. A star B is given LCM of A and B. Now whatever may be the binary operation, so when you perform A star B, the LCM of A and B should be inside this set only. So the third element, when you perform A star B, what are the value maybe it is, then C should belongs to this set only, from this set. Then only we say star is a binary operation. So this can be verified through this table. So here I have taken the binary operation star, which is nothing but LCM of A and B. I have taken the elements 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Let's write the LCM of these with respect to the other numbers. 1 star 1 means LCM of 1 and 1, it is 1. LCM of 1 and 2, 2, 3, 4, 5 here. Now 2, 1 is 2, 2, 2 is 2, 2 and 3 is 6, 2 and 4 is 4, 2 and 5 is 10. Next, 3 and 1 is 3, 3 and 2 is 6, 3, 3 you will get 3, 3, 4 you will get 12, 3 and 5 is 15. Next, 4 and 1 is 4, 4 and 2 is 2, 4 and 3 is 12, 4, 4 is 4, 4 and 5 is 20. Next we have 5 and 1, 5, 5, 2 is 10, 5 and 3 is 15, 5 and 4 is 20. So 5 and 5 is 5 itself. So clearly you can see star is not binary operation. We can also take any examples to show that it is not a binary operation, but this can also be verified with the help of operation table also. Justify your answer here. We don't find any element 6, 12, 15, 20 in the given set. So therefore, star is not a binary operation. Next question. Consider the binary operation on the set A 1, 2, 3, 4, 5 defined by A minima B. You have to take A star B in the form of minimum of A and B. Write the table for the operation. So again, this is nothing but you have to take minimum from A to B. So from 1 and 1 it is 1. Here it is 1, 1, 3, 1, 1, 4, 1, 1, 5, 1. 2, 1, 1, 2, 2, 2, 2, 3, 2, 2, 4, 2, 2, 5, 2. So minimum of 2 and 4 is 2. 2 and 5 is 2. Like that. 3, 1, 1, 2, 3, 3, 3. Next we have 1, 2, 3, 4, 4. Next we have 1, 2, 3, 4, 5. So clearly all the elements inside the operation table belongs to set A. So therefore what I can write here, star is a binary operation on set A. Thus we have verified through the binary operation table. Next one, Consider a binary operation star on set A 1, 2, 3, 4, 5 given by the following multiplication table. Compute 2 star 3 star 4 and 2 star 3 star 4. E star is commutative. Compute 2 star 3 star 4 star 5. So let us take the first one. We have to solve 2 star 3 star 4 and 2 star 3 star 4. So what is 2 star 3 here? It is 1. Star 4. 1 star 4 is 1. Next here we have 2 star 3 star 4. 3 star 4 is 1 and 2 star 1 is 1. So clearly we have found the values. Is it a commutative? So this is the first question. Second question, is it commutative? See here, 1 star 2 is also 1, 2 star 1 is also 1. 3 star 2 is also 1 and 2 star 3 is also 1. Similarly, you can clearly say, so A star B is equal to B star A. Therefore, star is commutative. Next question they have asked you that compute 2 star 3 star 4 star 5. So what is 2 star 3? It is 1. What is 4 star 5? It is 1. What is 1 star 1? It is 1. So the answer is 1. So by looking at the given table, we can compute the given results. Next question. E star B, the binary operation on N, defined A star B is equal to HCF of A and B, E star commutative, E star associative. Does there exist identity for this binary operation on N? So here, let me take an example of 2 star 3. So 2 star 3 means it is HCF of 2 and 3. So HCF of 2 and 3 is 1. So that means HCF of 2 and 3 is 1 means clearly it belongs to the set of natural number. So this is completely defined on the set of natural number. So therefore I can write star is binary operation on N. Second one, they have asked you whether star is commutative. See here, 2 star 3 is nothing but HCF of 2 and 3. So A star B is nothing but HCF of A and B, which is same as HCF of B and A. So therefore, it is nothing but B star A. So A star B is equal to B star A. So therefore, what I can conclude, star is commutative. So we have to show that star is associative. So clearly for any 3 values of A by C here, for all A comma B comma C belongs to N, we have A star B star C is equal to A star B star C, which is nothing but HCF of A comma B and C, which is one and the same. So therefore, star is associative. The last question is, does there exist identity element for this binary operation on N? So it is not possible for any element to have the same identity element. For example, if I take 1 star 2, it means HCF of 1 and 2. So is 1. So that means I can say 2 is the identity element. But when I take 8 with 2, which is nothing but HCF of 8 and 2. What is HCF of 8 and 2? I am getting 8. So the same element, when you take HCF with other element, you will get back the same result, but it is different for another one. So you cannot find any identity element in the star A star B. So therefore, there do not exist any identity element. So thus for the operation A star B is equal to HCF of A and B, it is commutative, it is associative, but there do not exist any identity element. This is all about the binary operation. So a star is a binary operation under the set is a function. So we can also verify whether it is commutative, whether it is associative, or an identity or inverse element exists. Thus, this completes the chapter Relations and Function. We'll meet you in the next session with the new chapter. Until then, keep watching, keep learning, keep exploring. Thank you.